How long you guys gonna need? Like 2 minutes? 30 seconds? 12 seconds? 11 seconds? 8 seconds? 6, 5, 3, 2.5, 1. I can begin now? Do you remember prior knowledge here is that just a day or so ago, you guys produced position versus time graphs. You remember that? In those position versus time graphs, you were able to discern, develop, appreciate that the slope of the position versus time graph was the velocity of the walker in front of the detector. Would we agree to that statement? So we knew that slope had value. Today, we're going to look at this graph, and we're going to try and interpret what this is telling us about our object. And more importantly, we're going to see if we can come up with some information that relates to this graph about what's happening with this object. Before I do any of that, before I launch into it at all, at your table, talk to each other about what's happening. Come to maybe a consensus about what this graph is describing. Be careful. Anything we see in here is supposed to be a model of what's happening in the natural world. This is no different. I am actually modeling something that you could see outside or see inside the classroom. So this is not something that's fictitious or simply contrived. You could make this happen yourself. So let me ask you a few questions about what we're seeing here. First, is our object moving? Okay, so we know that we believe the object's moving. At time 0, what's the one piece of information we know about the object? Yes, sir.
Its velocity is 20 meters per second.
Raise your hand if you agree with that statement, that its velocity is 20 meters per second. Excellent. So we're talking about this point right here. And for those of you who are hesitant about putting your hands up, either you're hesitant because you don't know if that's true or not, or you're hesitant because you don't want to be wrong. But when I ask that question, I ask put your hands up, is to see who believes that's true and who doesn't. It's pretty bioptic, okay? So just pick a side and stick to it. Don't stay in the middle. But it is true. If I look at time 0, this graph tells me velocity at every moment in time. At time 0, it's 20. But it's more than 20. And here's where I want to be very, very critically pertinent. It is positive 20. This graph has both positive numbers and negative numbers, suggesting that you can have a positive velocity or a negative velocity. And that's not an accident. The idea that the velocity could be negative suggests that it being positive must mean something different than being negative. You guys follow that argument so far? And here's where I think my ideas about math and your ideas about math differ. You've been in a lot of math classes, but purpose has often been lost in your math classes, except just do it because you want the grade, which is probably how you feel about this class too. But I want you to understand that math is actually quite elegant in what it can tell us. We've already talked about the idea that velocity is different than speed because velocity indicates direction. It's a vector quantity, and therefore direction is an important idea in that quality. We're going to focus for the next couple of weeks. Positive and negative is perfectly acceptable. This object starts moving in the positive direction. I'm going to tell you what this is a picture of, by the way. This is me throwing a ball up into the air. That's what this is a picture of. I want you to think about it for a moment. When you throw a ball in the air and you catch it when it comes back, what does that look like to you? Imagine it in your mind. Imagine the entire trip the ball makes. Detach yourself from the idea, watch somebody else throw the ball into the air and catch it on the way back down. You know what it looks like now, right? Do you see how this graph is the picture of that idea? Let's take a look at what I mean by that. When the ball leaves my hand, it's leaving at 20 meters per second. I have decided by the choice on my graph that upwards is positive. I've made that decision for us. that automatically means downwards is negative. So in the end, if I find my answer and it's negative, I can erase the negative sign and just write the word downward. Because that's what the negative tells me. So if I find that the displacement is negative, that means it went downwards that many meters. If I find that the acceleration is negative, it means it was accelerated downwards. That's what the negative sign now means. If the answer is positive, don't throw away the positive. Positive means upward. The direction is up. If you're asked for a vector quantity, you have to give the direction as part of your answer. And it's always best to interpret the direction. 3 of those words are vectors: displacement, velocity, and acceleration. If you're asked for those, you better tell me what direction the object's traveling. So, moving on. After 1 second, how fast is the object traveling? Asking how fast is asking speed. I'm not asking direction. Again, after 1 second, how fast is the object traveling? Yes, ma'am?
10 meters per second.
How many would agree it's 10 meters per second? Excellent. I'm going to just, is it moving up or down still?
Still going up.
How do you know?
Because it's still on the positive side.
Excellent. You guys heard that too? So basically, yes, sir.
So if you're like throwing a ball, if its velocity is positive, it's still going up, and then once it hits 0, now it's falling back down.
Well, let's handle the up part, and we'll get to the down part in a minute. We know it's going to come back down. I'm not saying you're wrong. This part from here to here is where the graph is positive, suggesting that during that entire time, the object is moving upwards. Is the object speeding up or slowing down during that time? You guys all agree it's slowing down? Is the number part of the velocity getting smaller? So it's going up, it's leaving, it's going away from you, but it's slowing down the whole time. Is that your experience when you throw something up? Does it slow down on the way up? Sure. Seems good to me. Keep going, am I all right so far? I'm just going to write slowing down here. All right, it reaches this magic point at 2 seconds. What's the speed of the ball? 0. It has stopped. After 2 seconds, is the velocity positive or negative? So at 3 seconds, can you hypothesize as to what the velocity is? You did a great job. I want to see somebody else do it. Thank you. Let's see. I've not called on you. Go ahead.
10 meters per second.
Is it positive or negative?
Negative, so it's going down.
So would you all agree 10 meters per second downwards? Excellent. Excellent. So at 4 seconds, what do you think? Can I get an all call? Negative 20 meters per second sound good, or 20 meters per second downwards? So, is the ball speeding up or slowing down? All right, I like that so far. This is going good. So, this section speeding up, top section slowing down. All right. Are you ready to dive into the hard stuff? All right. Do me a favor, please. Could you calculate the slope of this line? Take a few seconds and calculate the slope of this line. Now, what did I do? Here, hopefully you found the slope already as being negative 10. Any problem with that? So, the units, though, to me are very important here. It's negative 10 meters per second on the top, seconds on the bottom. That would be the fraction, right? Because if I go back 1 step, it would be delta V over delta T. Right? V2 minus V1 over T2 minus T1. Rise over run. This is a rate then, because there's seconds in the denominator. This is the rate at which the velocity changes. Yes, sir?
Could you put it as meters over seconds squared? Because it seems like
You could, and you could reduce it down that way. In fact, that is the accepted way to write this unit, is meters per second squared. But that doesn't really convey the meaning. That's why I'm writing it like this for this moment, to convey with you guys what this idea is telling us. And I'm not trying to minimize your contribution. I will almost always write it as meters per second squared. The reason I'm spending such an enormous amount of time to talk about this one slope is acceleration is the most important concept in all of Newtonian mechanics. And although you don't understand this yet, anytime something accelerates, there was a cause, whether you can see it or not. In all of physics, that's the most important idea, is to find the cause for acceleration. Because a lot of times, the cause is invisible. Look, if I drop my pen, it accelerates, doesn't it? It will fall to the ground. What's causing it? Yeah, we have a word. I love words like that. It's similar to words like love and capacity. They're words that you use all the time, but I'm not sure you know the meaning of them. You know what they connote. You know what they exhibit emotionally, perhaps. But could you define it? Could you give me a definition of what it means? Gravity's tough. We often name things we don't understand. And when I say gravity's tough, I mean there is not a single person on the planet who can tell you what gravity is. They can tell you what it does. They can tell you how it behaves. But nobody knows what's doing it. Nobody understands it. It's a mystery, a complete mystery. All these things you think we know about, how smart we are, we actually know very little. We've come to grips with a lot of things. We're great at describing stuff. But ultimately, when we can't figure it out, we just name it. Name gives us power. You guys know that. Whenever you're worried about something, I must have this disease. At least I named it. Now I know what I've got. I got all those symptoms. Sure, yeah, I named it. That gives me power. Mm-hmm. It's hard. This concept's hard. So let me get back to the actual work here, because I want you to understand that this is how fast and in what direction the velocity is changing. We call this acceleration. Acceleration is the rate that the velocity changes. I've said it a couple times. I'm saying it again. I'm not writing the word acceleration down. It's a lot of letters, and I just don't want to. Acceleration is the rate that the velocity changes. Now, here's where I'm going to screw with you a little bit. This is a ball thrown into the air. What is the direction of the acceleration? You have two possible answers, negative or downward, right? The slope was negative. Negative means downwards. What direction does gravity act? I mean, this isn't hard. Gravity is what caused the ball to come back to your hands, right? So it's not like we don't know what worked on the ball. Here's the problem. The acceleration was negative the whole time. But clearly on the graph, does negative acceleration mean slowing down? Do you understand why that's going to mess with your sensibilities? The ball sped up and slowed down. But did the slope of this line ever change? No. Did it always have the same slope? Which means that for the entire 4 seconds, was the acceleration ever anything different than negative 10 meters per second squared? All right, so I throw the ball in the air, it rises, it stops. For that moment it stops, what's the acceleration? Do you hear yourselves? Do you hear what you did? Do you know where it stopped? On the graph, where did it stop? What time?
2 seconds.
2 seconds, right there. What's the slope of the line at 2 seconds? So it's not 0. I'm going to hit pause. That I will never say the word decelerate in here. Decelerate has no meaning in this class. It does not mean what you think it means. You have spent the last 17 years thinking that acceleration means speed up and decelerate means slow down. In this classroom, on my tests, and in all of nature, we have decided the word accelerate means to change your velocity. Whether that's slowing down or speeding up remains to be seen. I can't tell you if an object is speeding up or slowing down just because you gave me the acceleration. And I know you're not writing that down. We're really into this conversation, or at least you're looking at me like you are, but I would really make sure you write that down and highlight it. Knowing the acceleration isn't enough to know whether you're speeding up or slowing down. Knowing the acceleration isn't enough to know whether you're speeding up or slowing down. If you want to know that, you have to know what the velocity was. I need to have a starting point. All right, so I'm in my car. My car experiences an acceleration of 5 meters per second squared. I'm even going to tell you it's positive. Does that tell you anything about what the car did? It really doesn't. What if my car was traveling in the negative direction but had a positive acceleration? What if it was traveling in the positive direction and had a positive acceleration? What you need to come to grips with is that the acceleration tells you how the velocity changed. But you need to know what the velocity is or was to know whether that's causing it to have an increase in speed or a decrease in speed. Acceleration's tough. It's not as straightforward as you think. So, there's not a person in the room who wouldn't tell me that gravity pulls things downwards. There's not a person in the room who wouldn't say that it's gravity that's responsible for bringing the ball back to the ground. There's not a person in the room who couldn't say what causes this acceleration is gravity. Right? You all believe those things. Does gravity ever push things upwards? Does gravity ever cause things to go upwards into the air? Does it make sense then that if gravity is causing this, that it would always have a negative slope? It would always be a slope that indicates downwards? Because gravity always acts downwards. That's not crazy to think that. A lot of this goes against your vocabulary and a bit of your intuition. Let me be very clear, and this might be something to put in your notes if you're having a little bit of trouble understanding this, that velocity is not acceleration. I know that seems like a ridiculous thing to say, but that's why you have trouble. Velocity is not acceleration. You believe you have to have velocity to have acceleration, and you believe you have to have acceleration to have velocity, and that's not it at all. When you're in your car and you're stopped, it's possible for the car to have acceleration before the car has velocity. By definition, it would have to, wouldn't it? If acceleration is what causes the velocity to change, I have to apply an acceleration to the car. Then it will start moving. It will respond. You step on the pedal, but the car doesn't move until you actually do that. Right? You step on the pedals, car starts to move. That's exactly what you would expect. So the velocity kind of lags behind the acceleration. The acceleration is telling the velocity what to do. It's telling it how to change. It's in control. And if there's no acceleration, the velocity can't change. Okay, we're going to do something completely different now. Because I told you a long time ago, we haven't known each other that long, but I'm getting to know you. So a couple days ago, that you should always, when you look at a graph, consider what's happening to the slope and the area. let's explore the area for a few minutes. Now, this graph's area is a little interesting, isn't it? I see a triangle. Do you guys see a triangle? Now, since I believe this might be the first time you've dealt with the area of a graph, I'm going to have to lay some ground rules down. Area represents what is bound by the axes and the curve. The yellow line is the curve. It's the graphed data. If you don't know that, we always call it a curve, even if it's a straight line. So the curve is the graphed data. The yellow line is that graphed data. The white lines are the axes. So this graph actually has two areas. There's the one I've just indicated, that's red, and there's this other area over here that's blue. Two different areas. Because the area of the graph is the part bound by the curve and the axes. Luckily, those shapes are shapes I know, right? Triangle. So area 1/2 base times height. You good for that? That's how you do a triangle? No worries? You do know that, right? Luckily, this is a right triangle. So I'm going to say that this is the base and this is the height. Is that okay with you guys? So somebody tell me how long the base is. Just shout it right out. To what? Everything has units in here. All right, somebody tell me how high the height is. Yes, sir. Yep, but it's a vector, so I'm going to include the positive sign if you don't mind. Positive 20 meters per second. The height's the vector, it's a velocity, so I'm going to include that stuff. Now, I told you to get your calculators out because we're going to do some fancy calculating here. Right? So, can you do that fancy calculating for us? Good, 20. It's positive, and my units are meters per second times seconds. But what is meters per second times seconds? So, the unit of the area is in meters. Now look, this is the first time area seems to have a meaning. You have an idea here. It could be one or the other. It could be distance or displacement. Which one do you think it is? If you don't know, it's okay. Flip a coin. Yell one out. Well, that sounded like a lot of garbage. So I'll just tell you, it's displacement. It's a vector quantity. That's why it's displacement. It has direction. And displacement is a vector quantity. Distance is a scalar. It doesn't have direction. Now, here's the important thing. I'll call it displacement. Actually, delta x is the symbol I want to use for displacement. And it is positive 20 meters. Before the ball stopped, it traveled 20 meters upwards. That's what this told me. Does that make reasonable sense? A, that it would be upwards, and clearly it traveled some distance. So tell me real quick, what do you think that area is? You do see it would have to be negative. If you don't see why, it's still 1/2. The base is from 2 to 4 seconds. That is 2 seconds. The height, not 20, but negative 20 meters per second. Have to include the vector. It's on the bottom part of the graph, so it's negative. Which gives me a displacement of negative 20 meters. What was the total displacement of the ball? Yes, sir.
0 meters.
How many agree 0 meters? Yeah, I hope so. We said from the very beginning, we throw it in the air and catch it when it comes back. Where is it after it's been thrown? Back where it started. That's not a surprise. The math plays that out pretty well. Wait for it. What was the distance traveled? 40 meters, yeah. So look, displacement, you keep the signs and add the sectional areas. Distance, absolute value, and then add. That's the difference between finding distance and displacement. Displacement, you keep the signs. Distant, you don't. On one-dimensional motion. One-dimensional motion. Now, you might not appreciate this, but one-dimensional motion means you're on a number line. Now, a number line is not arbitrary, but it does focus our attention. So I want you to think about moving in one dimension. That could be going down that way in the hall, right? You can't really go left without falling off the railing. You're going that way until you reach a break in the hallway, correct? So walking to the media center, is that the positive direction or the negative direction? Doesn't matter. Here's what's important to know. Positive and negative is arbitrary. And I have found out over the last 5 years that you don't know what the word arbitrary means. So I'll explain it so that you don't feel, like you're lost when I say the word arbitrary. What it really means is that the choice you make doesn't matter. That's what arbitrary means. If you have a carton of eggs and I ask you to select one, the one you select is arbitrary. They're all eggs, right? If I ask for an egg, I didn't mean to ask for egg in quadrant 1. I just meant pick an egg. Do you really have to think about it too much? No. You do, however, have to grab an egg, not the carton, not something next to the carton. Now, I'm not trying to be facetious. When we decide what direction is positive, we are automatically making the other direction negative. So if I tell you out in the hallway that the media center is in the positive direction, and I tell you to walk in the negative direction, you understand clearly what that means now. So when we decide something is in the positive direction, we are assigning direction to the sign of the number. That's what that sign means. So if ever you are working out numbers and the number comes out to be positive, that means it's towards the media center. And if it comes out to be negative, it means it's towards the railing or the cafeteria. We have decided what we will call positive. The best part is that numbers and number theory automatically do this for us. This is how math was meant to work. I know that negative has come to mean something else for you. Often, it's come to mean something that you don't always appreciate. It started with takeaway. I have 3 apples, take away 2. How many apples do you have left? Right? That's where you started with negative signs. But you've probably learned now that negatives have a whole other group of meanings. How many of you have already had to take the square root of a negative number? Yeah. What is that? It seems like it got really bizarre really fast in mathematics class, didn't it? I promise you, all of these things have a unique integration and meaning. It's quite artful if you really look at it. But if you don't want to look at it, please understand that for us, for right now, we're going to describe vectors in one dimension. And the idea that there's slope of the position versus time graph is always going to be the velocity. Now, I'm bringing this up on purpose because if you're the kind of person who finds the 2 points, labels them, this would be x2 and t2, and this one would be x1 and t1. I'm not using y and x because I have x on the vertical axis and I have t on the horizontal axis. Okay so far? So this slope would, better. This slope will be x2 minus x1 over t2 minus t1. That's how you would find slope if you use the point-to-point formula. The top, yes?
Would it not be Tx instead of Xt? What is that?
Your ordered pair order?
Yeah.
Yeah, you're probably right. It's about that important at this point in my life. So, yes. But because they're labeled, I'm not worried about it. He asked an appropriate question, and he is right. I probably should have it T, comma, X. Now, the negative sign in there denotes the delta. You guys know that, right? So this is delta X over delta T. Now, there's a few things you should know about the way I look at this. And this is an accepted practice. Anytime the denominator of a fraction is time, we call this a rate. At any moment in life, if you ever see a fraction where time is in the denominator, the whole number is known as a rate. The rate at which something changes. This is the rate at which the position changes. That is the definition of velocity. The rate of change of position, given to you yesterday and the day before. If this were dollars and the bottom was time, it would be the rate of change of your money. Your economics class will have rate problems in it. Anytime time is in the denominator, we're dealing with a rate. So I go